Good day to my lecturer and fellow peers. My name is Nurin Jazalina Jaafar and my metric number is 2310211412. Today I'm going to deliver a verbal presentation for my media-based assignment under the course IMJ 32204 Computer Architecture. In this video, which will run between 5 to 10 minutes, I will be explaining the core characteristic of semiconductor random access memory or RAM. Furthermore, I will provide a detailed comparison between two main types, which is static RAM and dynamic RAM, and justify what type is best suited for cache memory and main memory. To build a strong foundation, let us first examine the fundamental characteristics that define RAM. Firstly, RAM is volatile memory, which means that RAM requires a continuous flow of electrical power to retain data. The moment of computer is turned off or lost power, all stored information is instantly lost. Second, it has read and write capability, not like ROM, but RAM allow the CPU to both read data from it and write a new data into it dynamically while the system is running. Third, it features random access, which CPU can access any memory location directly and in the exact same amount of time regardless of physical location or the sequence in which is requested. It does not need to search sequentially like an old magnetic tape. Fourth, it is semiconductor based. RAM is implemented using integrated circuit contain transistor and capacitor to represent binary state. Now, let us compare two primary types of semiconductor RAM, which is static RAM and dynamic RAM. We will look closely at their difference based on four key criteria, which is construction, speed, storage capacity, and power consumption. Let's start with criteria number one, which is construction. Static RAM is constructed using flip-flop, typically requiring 4 to 6 transistors to store a single bit of data, and it contains no capacitor. On the other hand, dynamic RAM uses a very simple structure, and it consists of only one transistor and one capacitor per bit of data. Moving on to criteria number 2, which is speed. Static RAM is incredibly fast, and its flip-flop design allows data to be accessed almost instantaneously, which perfectly match with modern CPU speeds. In contrast, dynamic RAM is slower because capacitor naturally leak charge, and dynamic RAM require continuous refresh cycles to retain data. This constant refreshing introduces latency. Next is criteria number 3, which is storage capacity and density. Static RAM has a very low storage density because each memory cell requires multiple transistors and it takes up a lot of physical space. So this will make a large storage capacity impractical. However, dynamic RAMs have a features high density because of the microscopic size of a single transistor capacitor pair allow billions of memory cells to be packed tightly onto a single chip. Finally, criteria number 4, which is power consumption. Static RAM consumes less power when idling because it does not require an active refresh mechanism to hold its states. But on the other side, dynamic RAM consumes more operational power overall. This is because dynamic RAM must constantly refresh capacitor even when the system is just sitting idle. Now, let us decide and justify which type of RAM is most suitable for cache memory and main memory. First, for question A, which is cache memory, the most suitable type is static RAM. Let me justify this choice based on 4 important criteria. Number 1 is speed. Cache memory sits close to the CPU and must keep up with its rapid processing cycles to prevent performance bottlenecks. Static RAM's high speed make it the perfect match here. So for number 2, which is capacity and construction, charge memory only needs to hold a few megabytes of temporary data. Therefore, the low density and bulky multi-transistor construction of static RAM are perfectly acceptable for this small scale application. Number 3, power consumption. Static RAM does not require continuously dynamic refreshing, which make it highly efficient for rapid CPU charge operation. Moving on to question B, which is main memory. The most suitable type is dynamic RAM. So here are the justification. Number 1 is storage capacity. Modern operating systems and heavy application require gigabyte of workspace. So dynamic RAMs have a high density which allow us to easily fit 8 GB, 16 GB or even more onto a motherboard. Moving on to number 2, which is construction and cost. Because of dynamic RAMs have a construction is so simple, just using only one transistor and one capacitor, it is highly cost effective to build a 16 GB of main memory purely out of expensive. Static RAM would be financially impossible and physically too massive for a standard computer. So the last one is power consumption. Even though dynamic RAM require a periodic refresh cycle to maintain the capacitor charge, but the overall power footprint for massive capacities is much more manageable and cost effective than an equivalent size static RAM array. So for the conclusion, both static RAM and dynamic RAM playing a critical complementary roles in computer architecture. Static RAM trade storage capacity for extreme speed, making it the definitive choice for charge memory. Meanwhile, dynamic RAM trades a raw speed for massive capacity and cost efficiency. So it makes the undisputed choice for our system's main memory. And that's bring me to the end of my presentation. Thank you very much for your time and attention.